Today we're in Unit 4, Lesson 3, and we're talking about solving systems of equations. So here's a couple of just overview things that you need to know. The first thing is, if you are looking at the solution to a system of equations, it's wherever they meet on the graph. Wherever two lines intersect or wherever they touch at is going to be the solution. So if you want to solve it by graphing, you just graph both lines, pick out wherever they meet, and then you write the ordered pair or the coordinate from that point. Remember, every coordinate is x comma y. If you want to solve it using the substitution method, here's your steps. And this would be a really great page to take a picture of so you could refer back to. But you're going to solve an equation for one variable, then you're going to substitute it into the second equation, then you're going to solve the second equation, and then you're going to plug that answer back into the first equation, and then you're going to check your solution. Anytime you get a final answer to a system of equations, your final answer should look like an x and y ordered pair. There should be an x equals value and a y equals value. So just another kind of general information thing. If both equate, when to use which method, because there's going to end up being three methods. You can solve by graphing, you can solve by substitution, or you can solve by elimination. So here's how I narrow it down in my mind. If both equations are in y equals form, then I always use Desmos and I solve by graphing, because you can literally just type it in Desmos and then find the point that they intersect and write down the answer. So if they say y equals, I always use Desmos. If one of the equations has so if they're not in y equals form, like one is x equals or 2x plus whatever, they just don't say y equals, then I look to see if one of the equations has a letter by itself. If it has a letter by itself, I use substitution, and if neither of those, then I use elimination. So let's jump right into some questions. And we're going to be dealing with more systems of equations in the future too. This is just the intro. All right, you buy 2 pounds of organic apples for $7.50. The graph shows the price of regular apples. What is the unit rate for each type of apples? So we got to figure out the unit rate. And remember, unit rate is per one thing. So we're going to find the unit rate for organic. It says that you spent $7.50 for 2 pounds, but the unit rate means just 1 pound. So we would divide that to see what it was per 1 pound. So we could go, where did my Desmos go? Here it is. So you could do $7.50 divided by 2, and it's $3.75 per pound. So that is the unit rate for organic. And then we could find the rate from the graph. And remember, the graph is for regular apples. And so for the unit rate is the slope or the rise over run. So I'm going to find 2 points on the graph, and I'm going to do my rise over run. I rise up 2 spaces and I run over 1 space. So that tells me that my the rate or the unit rate is $2 per pound for regular apples. Okay, so this one says the price of pears is y equals 3.25x. Which line would have the steepest slope if organic apples and pears were added to the graph? So remember, I changed my organic apples, so this isn't the one from the quiz, but my organic apples were $3.75 per pound. The pears are $3.25 per pound, and the regular apples, it's already in the graph, the regular apples were $2 per pound. So if you think about steepness, the one that has the highest rate of change is going to be the one that is the steepest, because it's going to rise up more than the others. So if you wanted to graph each one, the pears, I'll do it in green, you would go up 3.25 and over 1. So pears would look something like that. And then if you did the organic apples, which I think I had in red earlier, you go up 375 and over 1. So it would look something like that. So whichever one has the highest rate of change or the highest slope is going to be the steepest line. So on this example, it's organic apples, but remember I did change some of the values. So make sure you look at your values on the quiz. All right, write a rule for the function shown in the table. Okay, so when we want to write a rule, we did this earlier in the week, our rules are going to be y equals mx plus b, where m is the slope and b is the y-intercept. And for me, I like to find the b first, the y-intercept first, and the y-intercept is whenever x is 0. So my y-intercept is going to be a positive 7. And then for my slope, I need to find the rate of change. You could think of it as like a sequence. You could find the common difference. On this side, I'm adding 3 each time. On this side, I'm adding 2 each time. And we know when we do slope, you could think about it as rise over run, or you could think about it as the change in y over the change in x. Either way, we know that the y value, the rise or the change in y, has to be on top, and the x value has to be on the bottom. So this would be your function rule, y equals 2/3 x plus 7. All right, what is the function rule for the following situation? Rex paid $30 for a membership to a pool and pays $3 each time he goes to the pool. All right, so like we just said for our function rule, we're going to use this form, slope-intercept form, where m is the slope or the rate of change and b is the y-intercept or the starting value. So if we think about this, the rate of change, here, let me start at the beginning. He pays $30 for membership. That's his starting value. That's going to be the b value or the y-intercept. We're going to start at 30. It can't be less than 30. We start at 30. But then each time he goes to the pool, he pays $3 per visit. That's what's changing. If you go to the pool 0 times, you just pay $30. If you go to the pool 1 time, you pay $33. If you go to the pool 2 times, you pay $36. This is the amount that makes it change. So that's the rate of change. So when we go to plug it in, we're going to put our slope or our rate of change first, and then our y-intercept at the end. So that would be our rule. Now you don't have to have 3.00. You could just have it as 3x. Find the solution to the system of equations by using either graphing or substitution. Okay, so this is when it goes back to that first slide where I told you, try to figure out which method to use. And I said anytime it says y equals, the best and easiest method is going to be for you to graph them. So you would go to Desmos and you would type in exactly how it looks. You would say y equals, I already forgot it, 6 minus x. So y equals 6 minus x. That's the first line, and then hit enter or hit the blue arrow thing. And now we're going to type in the second line, which was y equals x minus 2. Y equals x minus 2. Okay, and then wherever they cross is your answer. So x equals 4 and y equals 2. So our answer is this ordered pair 4, 2. Remember, x is the y, x comes first, then y. So that's our answer. That's all we have to do. If it says y equals, we can go to Desmos and we can just type them in and see where they cross. So that's what I always check for first. Does this say y equals? Yes. Does this one say y equals? Yes. So I'm going to go to Desmos and I'm going to type these equations in. So y equals 2x minus 1. That's my first one. And then I'm going to type my second one in. Y equals x plus 3. So on this one, see how they don't meet up here? See how they meet up here, but you can't see it? You can zoom out. So you can hit this zoom out button or zoom in button, or you can just scroll on your mouse. But you want to be able to see in your screen where they cross. And you can always click on the point to show you the ordered pair. So the answer here, the x value equals 4 and the y value equals 7. So the answer is 4, 7. All right. And if you wanted to graph those by hand, I wouldn't suggest it, but I just want you to know, remember the b is the starting value, so you would start at -1 on the y, and then the 2 is the slope, so you would rise up 2 and over 1. This would be your first line. And then for your second line, this is the y-intercept, so that's our starting value, so we'd start on 3 on the y-axis. And then our slope, or our number with x, is actually 1, so we would rise up 1 and over 1. And this would be our line, and you would just have to keep extending those lines until they meet, and wherever they meet is your solution. So you can always graph these by hand too. If you have Desmos, why wouldn't you use your technology, right? So I usually use Desmos. All right, and then the last one, we're going to look first and we're going to say, does it say y equals? That one does. This one does not. It says y plus x equals 5, and Desmos is not going to graph that for you. Let's look at that. I don't think it will. So let's try that. Oops, go away. It says y plus x equals 5. If we tried to put that in Desmos, y plus x equals 5. Oh, it does graph it. Oh, let me make sure this graph is, yeah, that is correct. Oh my gosh. So if I were you, I would graph everything in Desmos because that's amazing. And the calculators that I used to use, like if you have a TI 85, like if you have your own handheld graphing calculator, it has to be in y equals form. But with Desmos, it doesn't have to be. Yay! So let's type them both in. The other one was y equals 4x. Oh my gosh, y'all, this is amazing. This made our life so much easier. Yay! Okay, so the point where they cross is at 1, 4. So that is our answer. Wow, I just learned something new. I didn't think that that would do that for us. That makes me really happy because it makes systems a lot easier. If you didn't graph, I'm just going to show you one with the substitution method because we are supposed to be learning the substitution method. But if I had the option, I would use the calculator more often than not. So with the substitution method, you take an equation that already has a letter by itself. So I'm going to take this first equation. And it tells me that y equals 4x. So when I go to my second equation, wherever I see a y, I'm going to substitute in a 4x. So in my second equation, I would write down 4x plus x equals 5. 4x plus 1x is 5x. And then divide each side by 5, and x equals 1. After you do that, then you have to take what you got for x and you have to plug it back into the original equation. So wherever we see x up here in the original equation, I thought I changed color, sorry. We are going to substitute in a 1. So we're going to say y equals 4 times 1. And then we would do 4 times 1, which is 4. And so to write your final answer, you would take your two answers and write them in an ordered pair. And remember, ordered pair has x first, then y. So this is the substitution method. And you can pick whichever one you like better. If you like substitution better, do it. If you like graphing better, which is my favorite, then feel free to do that one as well. And remember, with graphing, you just look to see wherever they cross. Where they cross is the solution for both lines. What will the graph look like for a system of equations that has no solution? Okay, a solution is wherever the lines cross. Well, if the lines never ever cross, then it would have no solution. So anytime you, and it doesn't mean that they don't just cross in your picture. Like you might graph a line here and you might graph a line there and they don't cross, but you know that if you extended them, eventually they would cross. So in order for there to be no solution, the lines have to be parallel. They have to be to the point where they would never ever cross. I'm going to finish this quiz on the next video.